Hello everyone, in this video tutorial, we will create a multimodal retrieval augmented generation system using LangChain and unstructured library in Python to chat with complex PDF documents like the PDF documents that contain text, images, tables, and plot. So we will be creating a multimodal retrieval augmented generation system that takes into account the images, text, tables, and plot and everything else that can be in your PDF document or the generation of a response. So as you can see, we will be creating a multimodal retriever augmented generation system using unstructured for extraction. So we will be using the partition PDF function from the unstructured library that helps us to read, parse, and split PDF into structured chunks of text, images, and tables. So the main library I will be using is unstructured library, which is available in Python. So I will be using the unstructured library from Python, and I will be using the partition PDF function from the unstructured library to split my PDF into structured chunks of text, images, and tables. So now I will just explain you the complete workflow over here. So you can see that I have created a complete workflow over here. So now I will explain you the complete workflow and then we will go ahead and then I will also explain you this Google Colab, the code that I have written in this Google Colab notebook. Okay. So we will be creating a multimodal retrieval augmented generation system to chat with our PDF documents that can contain text, image, tables, and plots. And the main library which I will be using in this tutorial is unstructured library, and we will be specifically using the partition PDF function inside this unstructured library so that I can split my PDF into structured chunks of images, tables, and text. So this is the most important library that we will be using in this tutorial. So let's go ahead and now I will explain you this complete workflow from start. So the step number one is extraction. So after uploading the PDF document, we will use the partition PDF function from the unstructured library to split our PDF into structured chunks of images, tables, and text. So the first step is extraction. After the extraction, we will have one array with all the images from the entire document. The other array will contain all the tables from the entire document, and this last array will contain all the text from the entire document. Okay. So now So after we are done with extraction, now in order to interpret the images, or you can say in order to summarize the images, we will use a multimodal model. We will use a language model with vision. So we will be using a vision language model. So you might be thinking, what is a vision language model? So a vision language model can understand the image. It can describe the image. So it is a vision language model is different from like an object detection model. A object detection model cannot understand or describe the image. So, but a vision language model can understand the image. It can describe what is inside the image, and we can also use a vision language model for optical character recognition as well. So in the step number two, we will be we will be summarizing the image. So for this, we will be using a vision language model that can understand the image and describe the image, and it can also summarize the image as well. So we will be using GPT-4o from OpenAI to summarize our own images. Then in the next step, what we will do is we will use a simple uh, text language model from Grok. So we don't need to use OpenAI model or a vision language model to summarize the tables or to summarize the text. So we will be using a simple text language model from Grok. So first we will extract the HTML representation of tables in a PDF using the unstructured library. Then we'll send the HTML representation of all the tables to the large language model, and we will create a summary of each of the table. Then we will also create a summary for every long piece of text. So the unstruct partition PDF function from the unstructured library will split our text using the section titles or the heading. Okay, so we'll split our text into chunks. Okay, so one chunk will be of introduction, the other chunk can be of the results, and the third chunk can be of analysis. So what we will do is we will split our text into smaller text chunk, and we can define like each chunk can contain like 1,000 or 10,000 characters. Okay, and the and on which scale we will be splitting our text chunk is that we will split our text chunk based on the section titles or headings. Okay, like introduction can be one text chunk, the result can be another text chunk, or results analysis or conclusion can be another text chunk. Okay, so we will use a simple text like based model from Grok. Like we can use llama 3.1 to generate a summary for all the long text. Okay, so once we have the summary for the images, tables, and once we have also have the summary for very long piece of text. Okay, so to summarize the image, as I told you that we will be using a vision language model from OpenAI, and to summarize the tables and text we will using an open source language model, text language model from Grok. Okay, so now after we have the summary for the images, tables, and text, then we will then we will convert our text into vectors. Okay, so we will creating embeddings. So why we need to convert our text into vectors? The reason that we convert our text into vectors is that we need to compress the size of the input data. So we will be converting our text into vectors. So for this we will be using an embedding model so that we can convert our text into vectors. Okay, so vectors are basically numeric values like 1, 2, 3, or floating values 0 0.1, 0 0.2, 0 0.3. So these are the uh, vector values. Okay, so to compress the size of our input data we need to convert our text into vectors. Okay, so once we create embeddings or the summaries we have. Okay, so in bending, what we do is in embedding, we basically convert our text into vectors. So once we have the embeddings for the summaries, then we'll save those embeddings into a vector database. We will use Chroma as our vector database. You can use Facebook AI similarity search as your vector database as well. So these are the offline vector databases. You can also use an online vector database, which is Pinecone as well. In this course, we will also see different vector databases as well. So in this tutorial, please remember that we will be creating embeddings for the summaries. We are not creating embeddings for the original text. Okay. So what we are doing is that we are generating a summary for all the text. We are also generating the summary for the tables. We are also summarizing the images. Then what we are doing is that we are generating summary for so then what we are doing is that we are creating embeddings, like we just convert our text into vectors. Okay, so after we have the summary for the tables, images, and text, then we are just converting text into vectors. Okay, then we are just saving those embeddings into our vector database. So when the user asks a question, like user can ask what is attention mechanism. So then when the user asks a question, we basically create embeddings for the user query. Then we basically perform a similarity search, and then in the similarity search we try to extract like top 4 or 6 answers based on the scale the user has defined. Like if the user has set the values like 4, it will extract the top 4 answers based on the user query from the vector database. Okay, so when the user asks a question, it create embeddings for that user query. Then it performs a similarity search and extract top 4 or 6 answers based on the value the user has defined in the code. So it extract top 4 or 6 answers from the vector database. Okay, so after we have retrieved the this on data from the vector database based on the user query, then we merge that data, which is in the form of context, with the query, and then we pass it to the large language model, and the large language model then generates a natural response and pass it to the user in the form of output. So this is a quick overview or the quick explanation of the workflow. So first of all, we will using the partition PDF function from the unstructured library to split our PDF into structured chunks of images, tables, and text. Okay. Then we will be using vision language model from OpenAI GPT-4 Omni to summarize all the images. Then we will be using text-based model to summarize all the tables. And then we are also using Llama 3.1, which is a text-based model from Grok to summarize all the long piece of text. Okay. So of us, we have the summary for the images, tables, and text. Then we will be creating embeddings for those summaries. So what we do is we use an embedding model, an open source embedding model, to create embeddings for the summaries. Okay. So embeddings are nothing but just it's a vector representation of the input of the data. Okay. So why we need to convert our input data, which is in the form of text, into vectors, so that we can compress the size of the input data. So to compress the size of the input data, we are converting our input text into vectors. Okay. So for this, we are creating embeddings, and I will be using an open source embedding model so that to convert our text into vectors. So once we have converted our text into vectors, then we will save our uh, embeddings into a vector database. I will be using Chroma vector database. Okay, you can use other like Facebook A similarity search vector database. You can also use Pinecone, which is an online vector database as well. So after we have saved our input data into a vector database, when the user asks a query, we basically create embeddings for that query. Then we perform a similarity search and we extract top 4 or 6 answers from the vector database. So in the code, the user define like if he wants to extract a top 4 answers or top 6 answers from the vector database. So after we extract the top 4 or 6 answers from the vector database, which will be in the form of context, then we just directly pass the user query and the data that we have extracted from the vector database to the large language model, and the large language model then generates a natural response, which will be provided in the output to the user. So this is a quick explanation of the complete workflow. So let's move towards the code part. So here you can see that I have created a complete Google Colab notebook over here. So you can just check it out over here. So first of all, I will just reconnect it from here. So the most important library I will be using in Unstructured, like you can see. Then we will be using Chroma DB, which will be our vector database to create. I am also using LangChain. So we use LangChain library to create different applications using large language models. Okay. So like LangChain Grok I'm using over here so that I can access text-based model like Llama 3.1 from a Grok. Then will also be using a vision language model like GPT-4 O Mini so that I can summarize the images. So I will be using GPT-4 O Mini from OpenAI. So therefore, I am importing library LangChain-OpenAI. Okay. So the package installation is still in progress. So this will take some time. So let's wait for the package installation to finish. Then we'll go ahead. So I have already explained you all the purpose of all these libraries. So we will be using the partition PDF function inside from this unstructured library so that I can split my PDF into structured chunks of text, images, and tables. Okay. Then we are using ChromaDB as our vector database, and we are using LangChain so that we can build different applications using large language model. We are using importing LangChain-OpenAI. We are installing this LangChain-OpenAI package so that we can access a GPT-4 or mini model from OpenAI, which is a vision language model. Okay. So we have installed the packages. So I'm just hiding the output. Next, we just need to install this library as one popular dash utils. So now I will just download a sample PDF file from my Google Drive. So we will be splitting this PDF into structured chunks of text, images, and tables. Okay, so now you can see this. We have this PDF over here. So if you just want to see this PDF, okay, let me just show you. So this is the PDF and this is about the paper. Attention is all you need. Okay, so this is the title of the paper and you can see we have this complete paper over here. Okay, so we have different tables over here as well. Like you can see, uh, we have this table. We also have different images over here as well. So let's start it. Okay. So attention is all you need is provided by Google. Okay. So let's start with this. So we will be doing a conversation with this, with the content that we have in this paper. Okay. So now what we will do is I will be importing partition PDF function from the unstructured library. Okay. So So now you can see that I have also defined over here partition PDF is a function from the unstructured library that helps you read, parse, and split PDF into structured chunks of text, images, and tables. Okay. So let's run this. In the meanwhile, I will explain you all the arguments over here we have. So first we have the file path. So now you can see that above I have defined the file path over here. So you can see this is the file path of our PDF file. Okay. So this is the first argument we have. Then in the second argument, you can see we have inferred table structure is equal to true. Okay. So I will be explaining you each of the argument. I have also added details about each of the argument over here, but I will also explain you each argument as well. So in the file name, we have passed the PDF file path over here. So if you set inferred table structure argument is equal to true, so this will allow partition PDF function to analyze tables in the PDF and extract them in a structured way like in the form of rows and columns. But if you set this argument false, then it will be extracting the tables in the simply in the form of plain text. Okay. The next we have is strategy, which I have set to high res. Okay, so like you can also set it to fast as well. But if you want, if you are working, if you have tables in your PDF document, I recommend you to use strategy as high res because it uses, if you set a strategy as high res, it will use a vision language model to get text, images, and tables accurately. Okay, so you must set the strategy as high res if you want to detect the tables and images in your PDF document. Okay. The other strategy is fast, but it is not very accurate in in getting the tables or images from the PDF document. Then we have the extract image block type, and here you can see I have passed the image and table both arguments over here as well. Okay, so this basically tells the partition PDF function which type of visual blocks you want to extract. Okay, so it will extract the images like normal in the like normal pictures it will have. It will also extract the tables in the form of images. Okay, so sometimes the tables are not recognized as text. So if you set the extract image block type in this, if you pass both arguments image and table, so it will also extract tables in the form of images. Okay, next we have the extract image block to payload is equal to true. So this basically embed images as base 64 data. Then next we have the chunking strategy by title. So like we will have a very long piece of text in the PDF document. Okay, so we will be splitting our text into structured chunks. Okay, so if you set the chunking strategy by title, so it will create chunks by section headings or titles. Like one chunk we can have a one chunk of introduction, we can have another chunk of conclusion, we can have another chunk of results analysis, and we can have another chunk of like details about like some other details or some other information, like we can have other chunk of like search or something like any heading. So if you just set the chunking strategy by title, so we will be splitting our text into text chunks, and we will be creating text chunks based on the section headings or titles that we have in our document. Like we can have a chunk of introduction, the other chunk can be of the conclusion, the other chunk can be of results analysis, all this. Okay, so this is like how many maximum characters that can we have in each text chunk. So each text chunk can have maximum of 10,000 English characters. Okay, so if now we have combined text under n characters, so if a chunk contain less than 2,000 characters, we will combine that text with some other text chunk. Okay, so new after n characters, so we will be creating our text chunk after we have 6,000 characters in our text chunk. Okay, so now going ahead, let's see what types of element we have in our chunks. Okay, so we have so this is the type of element that we have in our text chunk. Okay, so now I'm just printing the first 1,000 characters for each from each of the text chunk over here. Okay, so you can see over here. Now let's see what different type of data we have over here in options. So we have images, text. Okay, so now you can see that although we have tables in our PDF document, but you can't see tables over here. So now um, if you want to see the tables, so we also have the tabular data in our text chunks. So if I just want to show you over here, so now you can see over here we have this data that we have extracted from the table. So here is our data that we have extracted from the tables. So we have 4 tables in our PDF, and so each row correspond to the data that we have extracted from each table. Okay, so now you can see we have layer, type, complexity, per layer, sequential, maxim, path, length. Okay, so here is our PDF. So now you can see over here we have the layer type, complexity per layer, sequential operation, maximum path length. Okay, so now you can see over here layer type, complexity per layer, sequential, math, path length, operations. Okay, now you can see over here we have the self retention, recurrent, convolution. So you can see that we are able to extract all this. We are able to extract all the data from these tables as well. Okay, now you can see that we let's see other table. So this is the table number 2. So we have model, BLEU, training cost, all this. So you can see that model, BLU, training cost, all this over here. Okay, so now in similar way, now you can see here is our table 3. Okay, so now you can see we have all extracted all the data of this table as well. Now this is our table 4, and you can see that we are able to extract all the data from this table as well. Okay, so now you can see that we are able to extract all that data from the tables that we have in our PDF. Okay, so now you can see that we have created an array that contains all the tabular data that we have extracted, all the tables data that we have extracted from the PDF. So we have 4 tables in our PDF, and we have extracted all the data of these tables as well. Okay, so now as I told you that we have set, if you just see over here, we have set extract image block to payload is equal to true. So this will extract so now this means that we will be embedding images as base 64 data over here. Okay, so now we have around 7 different images in our PDF. Okay, so now we are just embedding images as base 64 data. Okay, so now we will separate extracted elements into table, text, images. So now we'll just create a list which will contain all the data that we have extracted from the tables. Other list will contain all the text that we have extracted from the PDF document, and the other will have other list which will also contain all the so we will also contain all the images, or you can say that all the images data that we've extracted from the PDF document in the form of base 64. Okay, so we have around 7 different images in our PDF document. Okay, So now you can see that we will be creating two different lists. One will contain all the data, all the tabular data that we have extracted from the PDF document. The other list will contain all the text that we have extracted from the PDF document. Okay. So now I'm just seeing printing. So now you can see we'll have multiple different text chunks, and we have created text chunks based on the section headings. Like you can see, this text chunk is about introduction, the other text chunk is about model architecture, the other text chunk is about attention. So you might be saying that the second text heading is missing. So as I told you that if our text chunk contain less than 2000 English character, then we will merge it with the previous text chunk. Okay. So now we have created text chunk based on the section headings, which you can see over here. And I was just printing first 22 characters for each of the text chunk. Okay. So now now we can see, just run this. We have 4 different tables, and I've also shown the data that we've extracted from those tables. Okay. So now we can just display the image as well. So we can decode the images. So now you can see this is our third image. So if I just show you, so this is the image that we have in our PDF document. Okay, so now as I told you that in the start that we will be creating the summary of all the images. Okay, then we will also summarizing the images in the form of text. We will also be summarizing the tables in the form of text. We will also be creating a summary for the long piece of text as well. Okay, so now to summarize the tables and the long piece of text, I will be using text-based model from Grok, and to summarize the images, I will be using a vision language model from OpenAI. Okay. So first of all, I will just install LangChain-Grok. So here you can see I have just passed a prompt. You are an assistant tasked with summarizing tables and text. Okay. So I will be using the Grok text-based model to summarize the tables and text. Okay. So here is the prompt. Okay. So here I am just summarizing the long piece of text that we have in our PDF document. So now you can see over here, we are just summarizing the very long piece of text that we have in our PDF document. So this will take some time before it gets finished. Okay. So as you can see that like this PDF contain around 15 pages long. So there will be a very huge amount of text that we are summarizing over here. Okay. And we are using Llama 3.1 8 billion parameters model to summarize this long piece of text. Okay. Then we will also be using this Llama 3.18 billion parameter model to summarize the tables as well. So now you can see that we have generated a summary for a long piece of text. The transformer model proposed by Google Brain replaces recurrent and convolutional neural network with attention mechanism, achieving superior results in machine translation tasks and requiring less training time. So this is a summary of the long piece of text that we have in our PDF document. And now we will be summarizing the tables as well. So now you can see that we have 4 tables in our the PDF document, and we will be generating a summary of each of the table. Now you can see that this is a summary of the last table, this is a summary of the second table, and this is a summary of the third table, this is a summary of the second table, and this is a summary of the first table. So let's look at the summary of the first table first. So now you can see over here. So we have this self-attention, recurrent, convolution, self-attention. Okay, we have the complexity part layer over here, sequential operations, maximum path length. Okay, so the table compares 4 neural network layer types: self-attention, recurrent, convolution, and self-attention. Okay, so now these are the 4 layer types that we have. Okay, So now you can see a comparison of four neural network layer types are presented in the table one. Similarly, the second table compares the various machine translation models. The third table appears to be comparing various deep learning models, and the fourth table compares the performances across different training methods and architectures. Okay, so we have the table summaries over here. So now we will be using a vision language model to summarize all the images that we have in our PDF document. Okay, so I'm just passing my OpenAI API key over here. I'm just installing the package LangChain-OpenAI over here. And here you can see I've just passed the prompt template, describe the image in detail for context. The image is a part of a research paper contemplating a transformer architecture. Be specific about graphs such as bar plots. Okay, so now we will be summarizing each of the single image that we have in our PDF document. Okay. So we have around 7 different images in this PDF document, and we are summarizing all those images over here. So now you can see that we are just summarizing each of the single image. So the first image which we have in our PDF document is this one. So this is a figure number 1. Okay. So let's see. The image illustrates the architecture of a transformer model commonly used in natural language processing tasks. Okay. So we have the input and output embeddings. Okay, now you can see that this is a transformer model architectures. We have the input output embeddings. So you can see that here we have the summary of this image in the form of text over here. Okay, so now this is summary of the second image over here. This is a summary of the third image over here. This is a summary of the fourth image we have. This is a summary of the fifth image we have. This is a summary of sixth image we have, and this is a summary of the seventh image we have. Okay, so we have image summaries, 7 different image summaries over here, and you can just check some specific image summary over here as well. So now you can see that we have this linear scale dot product attention, linear concat, and here you can see we have this image summary being provided over here. Okay, so that looks quite good. So now once we have the summary for the images, so we have the summaries in the form of text for the images. We also have the summary in the form of text for the tables. We also have a summary for this long piece of text as well that we have in the PDF document. So once we have a summary for the text, tables, and images, now we will be using OpenAI embeddings. So I will be using OpenAI embedding to convert this pieces of text which are in the form of tables, images, and the summary of the original text. So we will be converting this text into vectors. So why we need to convert our input data into vectors, so that we can compress the size of our input data. Okay, so after we create embeddings, or after we convert our input text into vectors, okay, so embeddings is just that we convert our input text into vectors. So after we convert our input text into vectors, then we save those embeddings into our vector database. So we are using Chroma as our vector database where we are saving those embeddings. Okay, so first we just convert all this text into vectors, which is what we do in embeddings. Like in embeddings, we basically convert the text into vectors. Then we just save those vectors into our vector database. So we are using Chroma as our vector database. Okay, so when the user asks a query, from here we convert the user query into embeddings, and then we perform a similarity search, and you can see that I have just set the value k value to 6. So this will extract the top 6 answers from the Chroma vector database. Okay, so we have not imported the libraries. So now let's run this. Okay, so now we are just formatting our response over here. So they are just formatting the response that we retrieve from the vector database. Okay, so now what we do is that we are using Llama 3.1 8 billion parameter models. Okay, so this is the large language model we are using. So once we retrieve the response based on the user query from the vector database, which is Chroma, then we merge the query with the retrieved data and pass it to the large language model, and the large language model will generate a natural response. So here you can see that the large language model we are using is Llama 3.1 over here. Okay. So here we are just passing the LM, we are just passing the prompt. Your answer strictly is from the provided context, like the data that we have retrieved from the vector database. Okay. So we are just providing the user question and the context that the data that we have retrieved from the vector database. As I told you that we will pass the user query and the context that we have retrieved from the vector database to the large language model, and the large language model will generate a natural response. Okay. So the query is the user question or query is explain the attention mechanism in detail. And let's see if you are able to get the. So now you can see that we are getting a very detailed response. The attention mechanism is a key component of the transformer architecture, which is used in natural language processing tasks such as machine translation, text, summarization, and question answering. Okay, so here is a detailed explanation of the attention mechanism. So here are the key components of the attention mechanism: types of attention like dot product attention, additive attention, scale dot product attention. How attention mechanism works: we have the multi attention details over here, we have the masking detail over here, and we have also have the summary. In summary, the attention mechanism is a key component of the transformer architecture. Okay, so now let's go ahead to the second question, like, which is explain multi-head in detail. So multi-head attention projects queries, keys, and values at times with different linear projections. In more detail, multi-head attention involves the following steps like linear projection, matrix multiplication, softmax, masking, scaling, matrix multiplication. Okay, so now you can see that we have all this information in detail, and we have asked two different queries, and we are just getting a very good response. Okay, so now you can see that we have created a multimodal retrieval augmented generation using unstructured library in Python. So it allows this multimodal uh, retrieval augmented generation system allow us to chat with PDF by taking into account the images, tables, and text and plots that we have in our PDF document. I hope you have learned something from this tutorial. Thank you for watching this tutorial.